It was not a bit difficult to move on. Yeah, so right now I'm part of two companies. One is called Takanal Energy, where I head everything. It's a startup. I'm a director. So yeah, right from operations, development, till the delivery, chasing the customers. People from the startup background will definitely understand. And there's another startup where I'm a co-founder that's into hydrogen mobility. Hydrogen mobility. I give more time to Takanal because that's my bread and butter. And hydrogen, we are expecting it to get into traction or into complete commercialization in another 4 5 years, not today. So that's my secondary thing that's slowly coming up, where we have already come out with prototypes and all. We are looking for funding, so that's in a slow pace right now. Yeah. So the topic is AI and future of electric vehicles. So mobility is no more like how it was 10 years ago. Today, every now and then, Nitin Gadkari will come and say that,
Hello?
uh, yeah, we are doing a lot of carbon emissions, reduce it. And on the other side, Modi will come and say that by 2045 we should go carbon neutral or reduce by 50% or whatsoever. So, of course, on one side, industry is a major carbon emitter. On the other side, the other major contributor for carbon dioxide emission is mobility. So you take it right from trains, ships. Ships probably they take gallons of what to say diesel per minute, I guess. And recently, I was seeing one of the document where it said that they use something called as heavy oil, whose carbon emissions are still higher. And people are moving to electric, whatsoever case it is. Whether because I had a small project or rather a consultant sort of thing with Mazagon Talk, who is into completely into shipping. So there, people are moving into electric, and I have got a collaborator. He works out of Swiss somewhere. They are majorly concentrating only to marine EV, where again they also have a lot of these people also being hammered a lot, where they are pushed towards EV. So I mean, of course, we know that uh, we know that Tesla is a major player. I was talking to someone. They said that BYD started in 2010, even before even people had heard of Tesla in China. Uh, and again, of course, in India, we know that Tata was a pioneer. Later on, now we saw. I mean, most of us would have seen whosoever is automobile enthusiast, the Mahindra new version, which was like crazy sort of a thing, which was driving the four wheel this thing. So mobility is not the same how it was we were looking. It is changing every day. I mean, people who doesn't know electrical, I've just given a small glimpse how in the PPT what all components come in electrical. So simple battery, motor. Of course, if engineers or non-engineers till 10th standard, you would have heard of Ohm's law, power equations. All these things are part of these things. So, where do, what is the fuel? I was talking that ships use uh, this thing. What is it? High density fuel or diesel whatsoever. Our regular bikes, cars, all these things use again petrol and diesel. So for electric, it is only power resource. Uh, there are major six power resources where few of them are non-renewable, few of them are renewable. So today India has close to 100 gigawatt of solar, which works only between 10 to 4 or 10 to 3 rather, and it works only 300 days. We have only that restriction. Of course, Rajasthan might do it 365 days. I don't know. If I take it Bangalore can do 300 days of solar. The rest 65 days Tata by to sun. We don't produce energy. Of course, wind does only 9 months or 8 months. The rest 4 months wind doesn't produce energy. Geothermal, I think only northern part of India has few systems around geothermal. So these are the ones that are into completely renewable, where we don't spend energy, or we do not what to say, disrupt any environment, and we generate energy. Next comes the nuclear, which is whose disposal of the nuclear waste is a big problem. Fossil fuel, which might be coal. How many? I don't know how many of you know that a lot of people use diesel generators to run data centers. That's a big this thing, what to say, carbon releaser. So I'm here linking two things. One is energy production, and on the other side, EV, which consumes all this energy. So of course, in between we have our present existing ecosystem, whether it is commercial, industrial, or whatsoever utilization. So we have to match these two. That is where a lot of algorithms come into picture. Uh, One step further, a simple way, if I see any vehicle, battery, motor, power electronics will come into picture. And now motor is one major thing, battery is the other major thing. Rest all I can use the existing system. So these are the two things. If I start playing around, I can optimize this. For example, I hardly drive around 5 kilometers a day, or worst case 10, not beyond that, unless it is a customer meeting where I have to drive long distance. So if I enable my vehicle with AI, it knows that okay, this guy is going to drive 5 kilometers one side. I need to have one side only this much. So optimization of power requirement. I'll come into that level, but I'm just giving the glimpse as of now. So it will say, okay, this power is sufficient to just throw this guy to office. Yeah, vehicle will do that. If I do not give, if my calendar would have the next meetings where I'm going. If it is online meeting, offline meeting, my whole schedule, my calendar knows. If I sync my vehicle into this, vehicle would know that okay, this guy is not giving me time to charge. I need to have more charge to reach this place. Okay, vehicle doesn't know that am I using the same vehicle, or I'm taking metro, but it can be ready for that. So that is where we are heading towards now already. If you see slide number 5, if I'm not wrong, the whole bigger architecture opens up. So there are multiple components. Tesla uses 4 motors in his cars. It doesn't use single motor, whereas Tata uses only one motor. It just puts up the put in the front, drive the back axle with the motor. It runs peacefully. Whereas Tesla uses 4 motors, so that their power consumption, all those, that's electronics and electrical stuff. I'll not get into much into that, but this is how a bigger architecture looks like. And thanks to AI, it reduced my effort to make the diagram. Uh, I mean, if I sit to this, it will take me easily 20 minutes to make this diagram. So I just described everything. Yeah, there are a lot of errors, but yeah. So my concentration right now will be towards two components. One is towards battery. In battery itself, you can see that multiple pieces are there. So battery has its own battery management system. Then it has conversions between themselves. It has to talk to engine control unit, saying that this is the present power what I have. This is what I can deliver. All those things. And motor has its own electronics. We call it as MCU, motor controller unit. So motor controller unit basically draws DC, and motors are AC to keep it efficient. I don't know how many of you do not understand ACDC. I'll not get into that again. So next slide, I say major component one, which is battery. So you can see how many cells. This is a Tesla battery basically. Left one is a old Tesla battery, and right side is a new Tesla battery. So you can see that how many cells are there, which is just like all of them are individual. Right side one will give more clear view. The numbers you can forget it. The numbers are size of the cell, so you don't have to worry on that. But on the right side, if you see, there are like multiple battery, which means that almost 32 kilowatts is close to what a home utilizes probably in 10 days or 15 days. That's the power that a Nexon battery has to provide. Each cell is being discharged when a car is being driven, which means that individual has its own data. I mean, we say that five fingers are not equal. Then how can I expect thousands of cells being equally performing? That is where BMS comes into picture, which becomes an edge device for me to send the data to the cloud. Now, I need to have a monitoring system at both the levels, edge level as well as in the cloud level, to start computing and make sure that all the cells are operating properly or not. So on the edge level, we have something called as BMS. It will be made out of ARM Cortex processors, so they do very good job. And I have a telematics unit, collects all data, just dump it onto the cloud. It will give me all the data. Like I've mentioned, 1900 cells data. It gives me all 1900 cells data. Now it is the job of the data analyst to start playing with it, where he comes out with an algorithm to handle all of it. And I have mentioned Tesla Cybertruck, 4,000 cells. Where does the which algorithm can handle it in real time? 4,000 cells, data will be coming every second. You can understand the intensity of that. I'm only talking of the battery. I'm not talking of current. I'm not talking of temperature that is increasing. I'm not talking about motor performance. I'm not talking about anything else. I'm only talking of cells. So you can imagine how the data is going to build up. And I've just shown how a fixed battery, I mean, or a battery that will be fixed. Now I was saying that each cell contributes. So this is the data which I in the sense Takan Energy works as consultant for multiple OEMs for developing their batteries for their two-wheeler, three-wheeler, four-wheeler, all such things. So this is one such data where I have taken that, like we have a complete R&D sort of a setup. So what did I do is, like at 25 degrees I started discharging a cell, at 45 degrees I started discharging a cell. I computed 100 cycles. There is something called as degradation, which I have mentioned for 100 cycles. And I have mentioned 14.82 was the maximum, and it went down to 14.5. That is age. How can I give this an example? Is, for example, when we buy a new mobile phone, it would hardly come for 2 days. I had a phone which used to come for 3 days. Samsung M51. It was called as Monster Series. So I used to get the battery for 3 days. Even recently, when I changed it, it used to still give me battery backup for 1 day. Battery almost lost its capacity, but still it used to give. Which means that for 3 years, its capacity has degraded. Same thing is going to happen in the electric vehicle. I don't know how many would have got a feedback from your friends who are using electric vehicle. They would have said that starting I was getting a mileage of 100, now I'm getting 60. So that is where all this detailed analytics we do when we start picking up a cell. Cells are given by LG, Samsung, which everybody know. There are unknown at least 60 companies which China provides. 60 companies, and every day India orders 40 megawatts of cells each day. I mean, it can be a company called CATL, Goshen, EV. There are multiple companies. I can just in my fingertips I have 10 companies apart from LG, Samsung. So you can see that at 25 degrees it is operating in a different way. At 45 degrees it's operating in a different way, which means that degradation is higher in 45 degrees. For example, mobile, if I'm using continuously at 45, Instead of 3 years, in 1.5 years, I'm losing the capacity. If I'm operating only at 25, it is coming for 3 years. This is just an analogy which I'm trying to give. Now, if I put the same thing onto the vehicle, motor is running, motor is nothing but a coil, consumes current, it has losses, which means that it has to deliver out in terms of heat. So it is starting heat generation from one end, which means battery starts degrading. Now you had only one dimension earlier, a degradation. Now a temperature has come into the picture. Once temperature can be 30 degrees, 25 degrees at night, 15 degrees at morning, probably 50 degrees. So you have a big curve now where the batteries needs to be analyzed, mapped to that particular temperature and degradation. Now I'll bring one more dynamics, which is called, we call it a C rate. I can explain it in terms of shift. A person can do one shift. One shift he does, he can peacefully work. We'll make him work two shifts. His efficiency goes down. Here, I have given an analogy of making the cell to work in 4 shifts, which means that a cell that can work for 1 hour peacefully, I'm making it work rigorously. In 15 minutes, the whole cell capacity is gone. So if I'm making that kind of a work, I mean, if somebody makes me work continuously 4 shifts a day, I'll be equal to dead in 1 year. That's what the cells also I'm showing, which means that in a vehicle, I'm throttling it always like driving in a super sports mode, which means that you are compromising on your data. Sorry, your cells. Your cells will degrade soon. Another dimension is coming into picture. So now it's already 3 dimensions I've already included. There is another fourth dimension which is self degradation. You keep the cell battery, you use it very minimal, but still it loses its capacity, like aging. How we age, cells also age. There is one, yeah, this is with respect to temperature itself. I have compared how the losses are at 25 and 45. So now multiple parameters have come into picture for cell. Now 4 parameters or 5 parameters with respect to 1,000 cells. You can understand or imagine how much server has to work, where you have to optimize. I'm not getting into algorithms because there are n number of algorithms, and most of you come from data background, ML background, or AI background. You people are better in that. I will not get into that level. I'm just giving you a glimpse where all the potential is. So prediction. Now I have a bike or a car. Now I need to know its prediction. Okay, let's assume 2 people drive it in a home. I drive it very calmly. Same bike is used by my colleague who will drive it always in sports mode. Now the battery is starting dynamically behaving. If I'm driving, I might get a mileage of 60. If he is driving, he might not even get 40. Battery is getting affected every time. Okay, so that is where prediction comes into picture. We even do something called as maintenance prediction. I need to know when the battery has to be changed. If I know particular cell has to be replaced, I have to be capable of doing it. That is when I can utilize the battery to its complete extent. And temperature, I have to try to keep them as low as possible. So add some material to it, keep the temperature low. Now that material analysis will come into picture. Tesla uses liquid coolant. They have also something called as phase change material, which will try to keep it low. Tata uses liquid. And how many cycles, I mean, each charge and discharge is considered as one cycle. How many cycles it has done. So now, all these days, for example, I used what to say, RX100. I go to the market, I sell it. Easily I can get 70, 80,000 because still people are fan of that RX100. Right? Take the same Ola or TVS IQ to the market. Can I do the same? No. People even don't know how the resale can be done until we have this data. Or else I know a client who has come to me is like, I'm getting into say second-hand sales of the two-wheelers. Can you help us out? So we have a machine where we start understanding the capacity and tell him that okay, this much percent it has totally lost. It is worth selling at this price. I do it at back end. He'll go and take care of the market. So all those predictions becomes very important. So trends of the battery capacity. That's what I'm always talking about. So each cell loses its capacity by 10%. Overall 10% is gone. First day it was giving 100, 10% gone. It is only giving me 90. Another couple of months, 80, 70. It drops on. And you abuse the battery when it loses its capacity. We say the total capacity is reduced by 20%, it has to be taken out of the road. It is not safe to be on road. But we see people have hardly driven 10, 12,000. They have already ruined it by 70, like 30%. That's because see, if I'm driving a ICE engine, internal combustion engine, petrol engine, I keep the throttle constant, which is not necessary in electric vehicle. Again, these are all the dynamics which I have not learned by driving, I have learned by doing data analysis. It is not necessary to throttle. We are even trying to link it up to Google Maps elevations so that where all throttling is necessary, where all throttling is not, needs to be little more. So we do load analysis, we do elevation analysis, based on which where we start saying to the motor controller, this is the minimum what you have to draw, this is the maximum that you draw. So vehicle starts becoming intelligent. Charging. So charging is one of the beautiful. I mean, it takes one whole day if I get into charging. People talk about fast charging. I don't know if somebody has heard of a company called Exponent Energy. They do something called as liquid cooled charging. They have a big gun. They'll attach it. They pass chilled water, like close to 0 degree water. They pass it into the battery, and they supercharge the battery. They claim to charge in 15 minutes. So no comments on the charging pattern, but this is how they do. Whereas Ola, Ether, even Tata Nexon, they have another other type of charges where they say that we charge it in 1 hour. That's a different charging. Why am I bringing this charging concept? Now I was talking about 4 shifts on discharge side. If I make this cell to charge at twice the rate it is rated for. For example, we get what 55-watt chargers these days or 65-watt chargers, correct? What if I put a 130-watt charger? Battery, I'm making it to charge in half an hour, 15 minutes. That kind of a thing. It is equal to making the battery or a human to work in 6 shifts in a single day, where battery gets deteriorated more if I'm charging or fast charging. Again, that's another data. Till now, we spoke only of discharging part of the data. And now I'm bringing one more parameter, charging part. And all those parts again, temperature, what kind of rate of charging you are doing, all those parameters will come here as well. So this is totally towards cells part. Now, what do you, I mean, a couple of slides I've put keeping non-electrical people also in mind, because I don't know how many of you even understand what is a grid. What is a grid? Basically, maybe energy. Few of would have heard of Pavgada solar power plant, which is second largest in India. So Rajasthan has India's largest and world's 11th largest. So I start generating power. It goes to all those big high tension wires, and it goes to something called as substations. Substations are in every radius of 5 kilometers, wherever it is. In every 5 kilometers, they have substations. Either the voltage will be very high. From there, for the distribution, they bring it down. They use all electrical equipment in between, step up, step down transformers. they handle it so that efficiency will be high, losses are low. Okay. Now, I recently heard this from one of the BESCOM people, not BESCOM, one of the KPTCL people. A village completely transformed into electric mobility. That village has close to 50 houses. So there are 50 electric vehicles, irrespective of the company, Chinese, Ola, all those things have reached to that village. Now, every 1 hour, substation is tripping. Substation is tripping in the sense substation is connected to the power generation. It is not able to handle the load. When do you expect someone to charge? Night time. Do I have solar at that time? I already mentioned that close to 100 gigawatts. 100 gigawatts, like let's assume one house uses 100 units. 100 units, like I'm talking about 10,000 homes or even 1 lakh homes using that amount of power at one point of time. That's 100 gigawatts. That 100 gigawatts falls down to zero at 4 o'clock. Now you are expecting people to charge at night, whether it is car or two-wheeler. Now I said 50 homes with 3 units, 150 units of energy you are driving at a single shot. Same time TVs are running, refrigerators are running. I don't know what else. If it is a village, definitely they'll start even running water pumps. With cities as well because we have industries. There will be a big failures. We don't upgrade ourselves now, we'll lose it. So now, what kind of solution we can come up for this? So that is where we say, what if I connect electric vehicle to the grid back? We are already talking of something called as BESS, battery energy storage systems. So what the plan is, put up a big container, 8 by 20 container, put cells into it, put all electronics into it, charge it when sun is available, and discharge it when sun is not available. That's what the plan is as of now. And each container costs 6 crores. Nobody knows when he will make money. The person who is investing, whether it is a government, whether it is a public or private funded agencies, nobody knows when they are going to make that money. And it is worth equal to 5,000 units. That's it. 5 megawatts is not a big number. Only 5,000 units. Okay. Again, there also we have those degradations, everything. So day one, if I'm putting 5 years, it would have reduced to 3.5 megawatts maybe. So that is something which is already happening in India as well. Now, instead of putting that specific BESS, why can't we charge our vehicles in the morning when the sun is available? Put it back to grid at night. Make some money out of it. Why someone will pay us? In Maharashtra, between power generation, if power generation between 8 o'clock to 12 o'clock per unit, they pay up to 40 rupees. Maharashtra is one of the worst affected power because every now and then they have power cuts because they are not able to meet their expectations. I have my vendors, my battery vendor is from Maharashtra. If I call him, sir, there is no power, I'm not able to work. That's how bad it is. And they pay up to 40 rupees at night per unit. So now, if we come up with something called as V2G in the morning, vehicle to grid, I'll charge my vehicle. Again, these are all algorithm driven. You cannot do it blindly. How can I do it people forget turning off stoves when they are going out of house. How do you expect them to connect to the grid or to the charger every day? So that is where we have to come out again with algorithms for that. The moment vehicle goes to the parking lot, it should get connected, start doing that connectivity with the grid. charge it. It should know the time. Okay, now it's time to charge. I know the calendar. This guy is going out or not. I know that. So this is the amount of energy which I should have. At night again, it starts the moment it goes out to home. It should know whether this guy has what all commitment he has, how much he's going to travel, pick it up, and decide the discharging to back to grid so that the again at the end of the day he makes small amount of money. So that is why I have highlighted patterns in that. So pattern recognition comes into picture. Yeah, so this is just the same block diagram. Why? No. So now, as I mentioned, algorithms is something that a lot of algorithms are not there. A lot of algorithms are not there. In Himachal Pradesh, we figured out that Google Map gives altitude as well. So we just opened the phone, we routed to somewhere. It said half kilometer. We were like, okay, fine, let's walk. Exactly in Darjeeling. We're like, okay, fine, chalo, we'll go by walk. When we started walking, then we figured out that there was an arrow mark saying that this much meters you have to go high, which we never, because I'm a Bangalorean. For me, it's a plain flat land. A half kilometer hardly would matters like 5 minutes, 10 minutes if I'm too slow. This thing we thought, but Google was showing 20 minutes there. There was no change in the time. Then after once or twice, we started recognizing that it shows the altitude as well. If I can bring it into my algorithm, see, I know the coordinates. I can get the altitude difference, which means that if I'm going down the altitude, battery is charging. This exercise also we have done. We took a Kona car to Kona is a Hyundai electric car. We took to Nandi Hills. Bangalore people, Nandi Hills is a what to say a getaway, a shortest getaway for people. So a small hill. When we started driving uphill, of course, mileage was dropping a lot. When I started coming down the hill, we could see regeneration and battery started charging back. This is where I'm talking about altitudes. So all those are again, we need to keep a track of data, get it, come out with the data algorithms. We have not reached to that level. We are, I mean, we in the sense, my team has not reached to that level. We are still in something called as digital twins, which I'll be bringing up next. This is where we have not reached to that level. People who are interested, who needs to solve problems, they can come out with these things. And there is a lot of traction for in the market. You can sell it to anybody. Yeah, digital twins is here. So what's a digital twin? Digital twin is not new to the market. Siemens did it in 2000 or 2010, if I'm not wrong. Very old concept. It was utilized only in manufacturing till date. How do I do it? I have a physical device, get the data. Now, I have already mentioned from where all do we get the data. If I'm traveling, altitudes is one point of data, motor is one data, battery is one data. Get all the data. And again, we are concentrating only on two parts, motor and battery. We are only concentrating on these two parts because for us, what to say, predictive maintenance comes from these two parts. We are concentrating only on that side. We are not concentrating on any other parts. So right now I have a vehicle, which is a device, and I have put a IoT device on that. Get the data from motor and battery. I know cells life, how it is degrading. Even I take cells individually charge, discharge in multiple variants. We do a lot of testing for TVS. We have done it for Ola earlier. Now I'm doing it for one more company called LS, which is part of Rajesh Exports. If people are into stock market, they would have known Rajesh Exports. They are India's biggest gold mining people. They are coming into electric. So for them, I'm doing self testing. So there itself, we do analysis and start building this digital twin. If I have these similar 1,000 cells, how are they going to behave? Now I get real-time data. I have already a simulated data or a data that I have tracked for a long time. Now I start matching it in real time. If not, adjust the curve and predict when this I have to take it out from the vehicle. So for this, you can use microservices. AWS has its own total solution built up, but whereas your what to say IP comes into picture, you have to build that algorithm. Digital twins comes out as a package. You have huge chunk of data on the other side. Now come out as a digital twin. That is where, uh, yeah, it is here. I've given the total what to say architecture itself, and this is a server based. I was recently going through some of the papers. uh, there I came across another architecture which says serverless architecture. I mean, I don't know yet. I have passed it on to my team also along with a paper saying that break your heads on this, try if we can implement this. So these are all the things that we are trying to do in my office, trying to solve problems. So I've already mentioned how these vehicles can act as storage devices, how economic benefits people can see, and environmental impact. Uh, I'll just give an example. Let's say Bangalore has 1.5 crores close to population. For 1.5 crores, at least there should be 10 lakh vehicles. At least 10 lakh vehicles. Let's say on an average they use 1 liter of petrol per day. That becomes 10 lakh liters of petrol. 10 lakh liters of petrol into 100. 10 crores. So per day we are burning 10 crores of rupees straight away. Now coming translate to that to sell, the cost is still more, but only thing is carbon. So now I said 10 lakh liters per day of petrol into 2.3 kg of kg of carbon. That is where environmental impact comes in. If I convert this to ton, so 2,300 tons. This is equal to 2,300 carbon credits, and each carbon credit is, I think, least minimum price what we have today in the market is close to $40. So 2,300 into $40. How much this is? Right, close to 10,000. Yeah. Okay, $10,000 per day. How much it is? 8 crores or
Yeah.
8 crores of rupees. That's the environmental impact plus monetization per day. What Bangalore can do? Okay, 10 lakh vehicles converted to electric. Can the grid handle it? That is where the challenge is now a big challenge. I'll tell even one more bigger challenge why electric vehicles is not getting traction. Or how much I have to travel? I said maximum worst case scenario. Even if I go meet multiple clients, I would travel 20 kilometers. How much would a porter guy or a Swiggy Zomato guy would travel? 100. What about Amazon delivery guys who come with big vehicles? 100 to 150. So there are particular vehicles. Beyond three-wheelers, they do close to 100. Beyond three-wheelers, Tata A's, all those things, they do 150. Okay, we have left out logistics. 1 hour they do 60 kilometers. Lorries, buses, all transport corporations, they do minimum 200 kilometers a day. So now I'll start moving. A bus comes with 250 units of electricity. 250 units of electricity, 4 buses if I put, that is equal to 1 megawatt plant. Okay. So now 1 megawatt, I'll put a transformer, it will handle that 1 megawatt. I'll connect 4 buses at a time. So substation gets a sudden requirement of 1 megawatt. Probably let's say in 3-4 hours and discharge completely. Disconnect. Substation loses that 1 megawatt load. Substation cannot handle it. At that point of time, electrician has to bring that substation down to keep it stable, or else substation will start having Deepavali. All the components will just go on fire. This is the big challenge what we have today when to move towards electric. So you can imagine how much training or algorithms would be required to handle all of it. So that's my session. Thanks. Would be happy to take the questions.
How is Tesla managing its truck infrastructure in US then? Because the same challenges would they have before energy cars.
So in even today in US there are totally only 1,000 fast chargers. Or if I'm missing 10, probably 10,000 fast chargers.
That would be for the cars, right? What about for the big trucks which?
That's what I'm saying. Fast charger itself so much. So the cars is Tesla something that has sold a lot. Then imagine for the lorries. Yeah, see, if anyone, Nexon comes out and says, I have two variants of batteries, 30 kilowatt battery and 45 kilowatt battery. 30 kilowatt battery they claim around 300, 350 kilometers. For 45 they claim 550 kilometers. You won't get 550. That by default we know from the petrol vehicle itself we know if they are claiming that 80% is what we get. Okay. Now this my CEO had got this consulting with Tata. Nexon they claimed it first variant. I think they had claimed around 350 400 kilometers. First variant, very first when they had launched, they were not even getting 200. Why? People started breaking their heads. They put it on the system. They are beautifully getting 400. Bring it onto the road. They are not getting 200. Lights, console, AC, all these things are powered by battery itself. I take the vehicle to Delhi in peak summer. No AC will work. I've experienced this in Hyderabad, by the way. My friends had we had to go to a wedding. It was peak summer. Afternoon was the wedding. This thing. One was Maruti, one was Honda, and one more was also in somewhere in same variant. Hyundai. All just above economical variants. None of the ACs are working. Because temperature outside is 45 degrees. How will I AC to work to bring down the temperature? Same thing will happen with the battery. Battery is a machine, is like, okay, you ask for 10 watts, I'll give you. You ask for 100 watts, I'll give you. You ask for 250 watts, I'll give you. You ask for 10 kilowatts, I'll give you. It is such a system. Your AC will start consuming more and more energy. As a regular driver, we don't know that it is hampering the mileage. That is where all the concept of range anxiety, the complaining, all this comes up, which we still do not understand. I mean, yeah, I understand. As a layman, as a regular vehicle users, people do not understand, which would take a lot of time.
One regarding the environment benefit. So, yes, in India, the percentage of solar generated power is not that high. Still dependent on fossil fuels to a great extent.
True.
Now, when we are saying we move to electric, we will save the carbon emissions. But in a way, are we not just shifting it from the city side of the world to the power plant side of the world?
Correct. So that is where the new scheme has come up. What is it? Ghar Ghar Solar. That is something which will be good unless you have capacity to store. See, simple thing. Again, I said 10 lakh vehicles are present. Definitely, there are 10 lakh roofs in Bangalore. I'm sure of it. 10 lakh roofs are in Bangalore. 10 lakh roofs, if I equip it with 3 kilowatts of anybody can take up 3 units. That is the minimum capacity of a meter that is there in any home. If I put a bidirectional so that I can send it back to the grid, so every day I generate 30 lakh units. I'm just taking the ideal number of 10 lakh. If I get into any commercial space, rather industrial space, I don't want to mention it as commercial, industrial. Industrial are those big 10,000 square feet, 20,000 square feet. So in 10,000 square feet, if I'm not wrong, we can put close to 100 kilowatts. 100 kilowatts is generating 4 hours, 400 kilowatts. 400 kilowatts of energy is generating in a day. If he can utilize this, store it somewhere, it will be just sufficient for his own purpose. Whatsoever bigger this thing. I missed your second question.
What about the
So
carbon
yeah,
emissions going to the
right.
remote parts of the country?
Yeah. So there are a lot of people who wants to buy. Specifically, iron industry people are eager to buy these carbon credits. I think which console? I think TVS. TVS shows how much energy or how much carbon you have saved during that travel or in total. Uh, uh, One of my friends told me that in Europe, particularly in England, when you choose a mode of transport, there it shows you like option one, you choose save so much of energy in general. You take a car, it will you will be spending so much of energy. You opt for a public transport, you reduce your emissions by so much. But again, we don't have any algorithm or technology or any app that can transfer these benefits to the end user.
So, regeneration of energy and putting it back to the battery. Want to degrade the battery.
No.
That regeneration is not available in the battery.
Simple. If you have seen some schools projects, they connect a motor to a lamp sort of a thing. You forcefully turn the motor, this lamp will blow up, which means that that motor is also acting as generator when you turn the wings or whatever it is. Okay. Same thing happens in this also. I leave the throttle. There we have a switches or rather MOSFETs, we call it as MOSFET transistors in the BMS. Two MOSFETs we will have. One is for separately for charging, one is separately for discharging. When I leave the throttle, I'll activate this charging MOSFETs. At that time, discharging MOSFETs, I'll pull it off.
So this will actually charge the battery, right?
This will
So
actually charge it.
then which means the battery charging and discharging cycle will increase. Right?
See again, there is something called as Samsung phones has this uh, battery saver option, something like this. It will charge only till 80%, 80-85%. It will not charge to 100%. Same thing we bring it into this also.
So if we charge within 80%, it won't degrade the battery.
Too much. It won't degrade too much.
Why not the regenerated thing? Say if you are doing a downwell or something like that, it will be reused within a very small span of time. Correct?
Correct.
Why not we uh, put this regenerated power in a capacitor
And
instead of putting it in the battery and then reuse it?
same
From
thing.
no,
Don't do the same thing.
no, no.
See, cells is nothing but capacitor. Cells are nothing but capacitors which are holding energy. Capacitors will do it in fraction of a second. Cells take its own time.
But if you have a chemical based or whatever,
Sir, to be very frank, I have come across people. My own prof, PhD prof, has called me up one day and is like, "You are working in EV." Yeah. So I want to put up superchargers, supercapacitors for starting duration. Like, what's the point? Batteries are capable of already doing it.
so can't we improve the battery thing just by doing this? Like
Extra cost.
just to parallel
Extra cost. Today itself already they are costly.
yeah.
Yeah, same thing as I mentioned. I work in hydrogen as well. There we are planning to implement this, whatever you are saying. We
Just to metal sheets.
not such metal sheets. We are putting whole bank of capacitor to handle the peak currents, charge discharge both. We have filed two patents across it. One is as a system, one as the one what we are talking about capacitor based. That we have filed the second patent 2 months back.
What is the maturity level of hydrogen based?
Hydrogen, the problem is it's a chicken and egg story like what we had in 2019. Where are the chargers? Why to buy the electric vehicle? Where are the hydrogen generation units? Again, in hydrogen, there are multiple types: gray hydrogen, green hydrogen, pink hydrogen, blue hydrogen. There are multiple types. So people say that until you are generating hydrogen using solar, it is not green. So there are a lot of chicken and egg story around that also. Until those get solved, hydrogen will not take off.
I think Hyundai is doing
Everybody are doing. Toyota has Mirai from 5 years. Hydrogen buses are existing in multiple airports from last 20 years. There are multiple things that are happening, but like now we are transferring the business from Middle East to China. All the lobbies are there now. The oil lobby is there. We have the cell lobby is also very bigger compared to oil lobby. Now, how do we come out of it? That is where it takes us to. That's another reason why hydrogen is not taking off so easily. People will tell everything. We don't have the storage unit. We don't have the thing that can convert hydrogen to electric. All those things we talk about. We have those things to certain extent, not 100% to certain extent. But there are a lot of lobbies that goes around to suppress this just because if their markets are gone.
yeah, but how safe is solar in itself? The recycling of the solar panel is very
You can do recycling. We do everything recycled today.
no, what about the mercuries and
Mercury is not there. We have tin. Tin will be there. Apart from that, everything is silica and glass.
so we don't have any cancer causing elements in the solar panels anymore.
No, no, no. Solar panels are more cost effective these days.
Cost effective, I'm talking about the
No,
recycling.
recycling they shred it. They totally shred it and make fine powder.
And it's environmentally safe.
No, they recycle it. They put it back. They're not disposing it. They're reusing it.
So it is there, like every available model.
Yeah.
You just in the interest of time, I'll pause the questions here. But after the second session, you can all continue the question and answers.
Thank you.
Thank you so much.